Hello friends, welcome to Eastern Academy. We are discussing about microprocessor. This is session 5 and this is part of our embedded system programming sessions. And today we are going to discuss about a very critical portion of the microprocessor that is called memory map. This is very, very simple, but the most useful one. You'll be understanding that at the end of the session. Let me be honest. We have already gone 1 week and this week. Actually, to be honest, these 2 weeks are sufficient to do lots of projects, to get into the good amount of embedded system practice. This week, that is, we have a class today and 2 more classes on Thursday and Friday. With that, and the last week, you can do wonderful. The 2 weeks are actually sufficient to get off for the embedded system programming. You do not have to even attend any other classes, but you have to only practice. Well, I'll discuss on next classes why these are useful. And today's class is a very tricky class, but that will be very useful one. You'll be I'll at the end of the class you will understand. See, I've discussed very important about microprocessor. This is what you understand top level. Microprocessor is a processing unit. That's all. Anybody ask, you have to say microprocessor processing unit. How it process? It has a ALU, arithmetic and logic unit. What is the arithmetic? Addition, subtraction, multiplication, division. That is adder, subtractor, multiplier, and divider. That's how that is the part. In the case of logic, and or not. That's all. They are there in the ALU. But the microprocessor is having also having a small memory. What memory? This is called register. Small memory. This is what all microprocessors in the world has. Small memory. We normally call R0, R1 like that. Okay, we don't call this as a memory. Even though it's a memory, we call it as a register. Then it has one more unit called control unit. This is called control unit. But what the control unit does is, it controls the communication between these two by getting the right instruction. Let us say we have about 8 wires. 8 wires. That means I can put 2 power 8, 256 instruction to the control unit. This is generally called opcode. The microprocessor from 1970, the first one, to today, 2022, they are all having opcode. Opcode is the one which tells the control unit what to do, but you don't understand. Opcode is a number. Do you understand what the 56 does? You don't understand. But if I say like same thing, move R0 to R1, you understand. So this is what you understand. This is what microprocessor understand. So what happened? This microprocessor manufacturer gives you the table. They like a dictionary. They give you move R0, R1 and 56. Like a Hindi to Tamil or English to Hindi, like that. This is a dictionary. And this language is called machine language. This is called assembly language. Both are same. Both are same. Understand? And the thing is that in every system, the process is in the middle. Process. You have input, you have output, you have power supply, you have storage. Since it's the middle, they call this a central processing unit. Understand? Now, that's why they call this as a short name, CPU, Central Processing Unit. What the CPU does is it can execute the instruction, that's all. It cannot do anything else. So what they have done is, this control unit gives the address. Control unit gives the address. Why it has to give the address? Because it takes the instruction from the memory. 56, 91, 73, 21, 45, 31, like that. These are all your instructions are there as numbers. Please understand, this microprocessor can understand a number, but there's also binary. If I write 31 means it's not 31, that is 0011, 1 is 0001. So the microprocessor understand only binary. Okay, so please understand. Now, this data comes from this guy. Who? From memory. I give the address, I get the data. Let us remove this now, because it's going here. This is called data. This is called address. Now, this is what normally we can do. Am I right? So this guy is going to execute the instructions only from there. That is very easy. But they done one extra change that has changed the whole world. That change was the biggest one in the history. What they thought was, hey, like human being's brain is having a small memory. Small memory. We have a small temporary memory. So if I ask you 4 plus 5 plus 9 plus 2 plus 3 plus 21, you cannot remember. Okay, you will note down on the paper. So people thought, hey, this guy is having only very few memory. So why this outside memory is very big. So why don't I use this memory to store here? So they thought, why don't we do this as a write and read? So please understand, the microprocessor does two activities in the memory. First activity is instruction read. The microprocessor can read only instruction. Who put the instruction? The programmer. We will discuss on Friday class how we are writing into the, let us say, in a PC, you write a C program. And the moment you compile, you get assembly. Then you get machine language. That is this. This is that in a laptop or PC. From the laptop, how do I store it to the memory? Okay, that we are going to discuss on Friday. That is very important for you. Then only you will have one doubt will be cleared to you. Right now, we assume that we are somehow writing into the memory. That's right now we have it. So what the microprocessor does is, it does not know what to do. So it knows only how to do things. It does not know what to do. That what to do is there on the memory. From there, the microprocessor reads one by one. This is at 0, 1, 2, 3, 4, like that. This is called instruction read, or people call it as a instruction fetch. So we normally use different terminologies somewhere. See, sometimes we call memory, sometimes we call storage, sometimes we call register, all are same. So sometimes we call latch, so many things, everything is same. Same thing here also. Instead of instruction read, we use instruction fetch. That means I'm fetching the instruction and executing. This guy the control unit will read it. Like if I have a notebook, you read line by line. Like that, the microprocessor can read line by line. So the first most important one is instruction fetch. What is the second one? That is very tricky. Second one is read data. Third one is write data. You may get confused. Hey, why I use the word here called fetch? Here, why I'm using read? Here, using write. Am I right? So, and what is instruction? What is data? Okay. Now, let me tell you the difference between these two that you have to understand very clearly. If I write the instruction in a C, int A, B, C, A equal to 10, B equal to 20, C equal to 30. Am I right? So A plus B. Let us say you are writing this. This is a very small program you write. The moment you convert the program, okay, what the compiler does one important thing. For ABC, it allocates a space. For A, it creates a table. For A, 1000. For B, 1001. For C, 1002. Assuming. Now I'm just taking that. So that means that the three places are allocated. A, B, C. We call these things as a variable. So this is very important for today's class. That's why I'm reviewing everything. I'm going quite slow, but I can go still slower. No problem. The moment you give a feedback to me on the now on WhatsApp, sir, I'm not understanding, I'll go still slower. Don't worry. Now, the thing here is, when I convert it, this A is equal to B, so I convert it assembly language. What is that? Move A, 10, so R0. Store R0 at A means 1000. See that this line is getting converted to, two lines in assembly. Understand? Same way, next line. B is equal to 20. Move R0, 20. Store R0, 1001. Because 1001 is a B. This is what your software compiler does exactly. Now, A plus B, load R0, 1000. 1000 is A. Load R1, 1001 and add R0, R1, R2 and store R2 into 1002. That is what I'm storing it in C. So forget about this. This week we can be, if you are very interested, let me know. I'll explain this in a special class also, no problem. And if you watch my videos, on the Udemy, you will be able to get it. I don't know, sir. You have created a Udemy account and sent me the mail. People have sent me the mail without having the account in Udemy. Okay, that's correct. So please understand, these are the, yeah, tell me.
Sir, this 1001, 1001 and 1002 which you wrote for ABC, is it the memory address or what?
It's a memory address. This is a memory address here.
So the compiler is going to allocate the memory address for the variables.
Correct. Yeah, this is called symbol table.
Okay, sir. That's just had it out.
For every symbol, that compiler allocates a address for that. That's a perfect. That's why normally people ask in interviews also. Okay, that's correct. How the exact every variable you allocate on the system, there is address associated with that. We call the variable, you call variable, in a compiler we call that as a symbol. This is a symbol. ABC are not numbers, they are symbol. For every symbol there is a variable. Now it's a trick here. Now what we do here is we convert based on the table, based on the instruction table, assembler, which you are going to write it as a part of our C programming. You will write a program to convert this into machine language. You will do that. You are going to do that. Once you are done about my 60 programs, then you will get into the assembler program. You will lot of people have written this assembler. Then the moment you write assembler, you will understand thoroughly. Even I have written compiler. When I was studying in the college itself, I written when I was doing masters, I've written compiler. Even though I'm an electrical student, I've written a compiler to convert C to assembly. And I did an assembler in you'll be very surprised. Converting an assembly language to C, I wrote it in a language called Fortran exactly in 4 hours. In 4 hours. That's that. You have to come to that speed, the programming. Now, see here. I convert this move R0, there is a 76 and 10. Then store R0, there is 45,000. Move R0, 91, 20. See, I convert each one into the number language. Done. This is done by the instruction set. We do it manually. The college also, when you're doing the microprocessor lab, you do this manually. Or you can write your own code. Now the trick is here. The most important trick here is, what is the most important trick? When this guy is executing, what you told him, A is equal to 10. It is there in the part of the instruction. When the control unit is executing that, when the microprocessor is executing that, what he does is, when he say store R010, he stores 10 here. He stores 20 here. He stores 30. He add the numbers and put the result here. This is called data. Understand? Your variable is called data. And this is called instruction or code. Please understand the difference between code and data. This is clear. Now do you understand the difference between code and data? Your code is only read-only. We don't write that. Your code will be always read-only. Read-only. The microprocessor don't write the code. The microprocessor is a slave. He follows your code. You have written in C in the computer, laptop. You compiled it into the assembly. Then assembler will convert it to machine language. You put it inside the memory. That's it. This is what the process you are doing. Now, after you have downloaded the code into the memory, this we are going to discuss on Friday or next session, how we are going to do that. Now, let us get into the point. Please understand the difference between data and code. Code is always read only, but data is read write. Because I have to write the variable. So, also, the moment I power on, please understand, this can be a volatile memory. But the ROM is a non-volatile because it has to be permanent. The moment you remove the power, the data goes off. Nothing will happen here. Let's say when you power on, this data gone, nothing will happen. But this data gone, when the microprocessor reads the data, it will not execute anything. So always your code should be in the non-volatile and read only. But your variable, see here, if you write a code, for example, int ABC, printf %d, comma a, this is wrong because you have not initialized, you have not written any value in a. You cannot print it. You should say a is equal to 50, then printf. Understand? So you write it to a and then print. Okay, that's important. So you always write first in the case of RAM. So when you write 50, 50 will be written here. Without initializing, you are not supposed to use the variable. Please understand. The variable has to be initialized first. Otherwise, it takes junk value. That is a problem with the We will discuss about the memory variables. There are so many things are the static, auto, so many things. We will discuss about that later. Don't worry about that. So this is clear. Now, here's a trick. Please understand this. This is which I'm telling you is the most important fact. You should know how to differentiate these two. All microprocessors in the world, have address wires. And they have a write wire. They have a read wire. And they have a data wire. Data can be used for writing and reading, both out as well as in. That's why bidirectional. Whereas read is only output. Write is, these are all commands, controls. These are called control. Telling the micro memory what I'm going to do. And address is the one tricky. Please understand the address. The very first microprocessor, 4004. Let me write it slightly left side, so you'll be able to have a good space. Address, write, read, data. See that? When I have only one signal, I don't put a slash. That means that this is only one wire. And these are all, when I put slash, it can be anything. The very first microprocessor, 4004, has address lines 12, data lines 4. Understand? Address lines 12, data lines 4. There's a beauty. That means that this microprocessor 4004 have A0 to A11. When I say 12 means, that is what? A0 to A12. That means this wires are 12 wires. A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11. Understand? This is what the 12 address lines. So I get 2 power 12, 4096 combinations, or we can write 4K. We can write as a 4K, 4096 combinations. So this microprocessor can use only 4K and it has only 4 bit. So the memory is only 4 bit. That's why the IC is too small. Now, then they come out with a microprocessor called 8008. That is 16 address lines and 8 data lines. That means that my memory is organized as 1 byte, 8 bit. And I have 2 power 16. 2 power 16 is 4K, 64K, 64K. That is 0 to 64K. Or you can write number means 65,535. Or normally if you write on hexadecimal, we write as 0, 0, 0, 0 to F, 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 F. You know that this is very simple, and watch our number system videos. That is, when I have 4 zeros, 1, 2, 4, 8. So the value from 0 to 15. 0 to 9 is 9. But 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. When I written F here, that is 15. 8 plus 4 plus 2 plus 1. That is what we write. So that means when I write here 16 wires, starting address is 0, 0, 0, 0. This is a starting address. So what we do here is we take this 4, and write as a 0. We take this 4, write as a 0. We take this 4, write as 0. We take this 4, write as 0. Easy to write. This is called binary. This is called hexadecimal. Am I right? The same way here, we write here FFFF. That means that 1111, 1111. These 4 ones or F. These 4 ones or F. So you have in between all the numbers. This is what the microprocessor. So if you take 8088, this guy had this. Then came was 8080. That also has same thing. They have not changed here. Then 8008, then 8080. Then came 8085. It's a very famous. 16 address line, 8 data lines. Then came with 8086. That has 20 address lines, 16 data lines. But they have a 8088. That has 20 address lines, 8 data lines. Then 8286. 24 address lines, 16 data lines. 8386. 32 address line, 32 data lines. It goes like this. Then they come to the processor called Pentium and all, where 40 address lines, 32 data lines. Then came out with the 40 address line, 64 data lines. But these two don't vary. They have a write and read only one. So the address keep on varying. That means that the first microprocessor I can address only 4K. But now, even now it's changed. It has gone to even 48. That means 256 tera. I can access such a very high. And what is the meaning of data changing 16, 32, and 64? That means that I can read more line at a time. Now I'll write it now. I'll write now. Now I'll tell you that what is that. We can call this as a N and M. Now it can be anything independent. Now, if I have a more address line means that very big program. This size vary. That is what? More address line means more data. Now you can write a very big program or you can have a very, very huge data. If you have a more data line means I read one line at a time or I read 2 lines at a time. If you use a CHAR in a C, you read 1 line. If you use short, you use 2 lines at a time. If you use long, you use 4 lines at a time, 32 bit. If you use long, 64 bit at a time. For example, if you put a 64-bit microprocessor, that means that I'll be reading them twice faster. I'll be very fast. Now, you have done now. This is what you have to understand. When you take any microprocessor, understand what is the microprocessor's address line. And if I say that it is about 16, this microprocessor can address out of 2 power 16 is 64K. Done. That's a maximum. Now the trick here is that's what for microprocessor. How do you access this? I write a program like this. Char, we assume that only 8-bit. We assume 8-bit. Let us not assume. If we say char star x, x is equal to 1000. Star x is equal to 25. What you are doing is you are giving the address 1000. You are giving the data 25. Since you are writing, write will be 1, read becomes 0. Understand? Now write is 1. Read is 0 because you are writing. But if I do like this other way, char star x comma y, put y is equal to, x is equal to 2000. Y equal to star x. Now you are reading. I'm putting it on Y. So now what happened? The 2000 will come here. And right becomes 0, read become 1. You know what I'm effectively saying that if I have a 16 wires from 000 to FFF, that is lost number. You can write anywhere. So as a programmer, you can write all memory location. Understand? You can write all memory location with the help of this. So this is called variable pointer. When I say int y, the y is called variable. Actually, we don't think we got to call it a variable data. We don't use that. That's a confusion we had. So now I write it like this. If I write a program, char x is equal to 40. That time this is data. If I write char star x, now star x is data. But x is address. But here also address is there. That is called and x. That is address which you don't see. That is who gives you, the compiler gives you a system table. So please understand, there are two things there. In the memory, I have two. One is called address. You mean English you may call what? Where? Or location. Or pointer. You call anything. You make all are same. Where? Address, location, pointer, all are same. And based on the place, we use different name. Where are you going? That we use it on English. Which location you are going? You're more specific on the street. And in hardware, we call that as address. In C, in a programmer, we call it as a pointer. And this is having what? What are you going to write? That is data. Then data in hardware. And location, content. What content is there? That is called in English. And pointer we call variable. You understand? It's a variable. Why we call variable? We are changing. So if you take in C programming, in a memory, this is variable. This is pointer. If you don't tell the microprocessor, you tell the microprocessor write 25. And he will ask where to write. That you should give him a pointer. The trick is that when you write a program now, when you write a program, int x or char x, all are same. All are same. This is 8-bit, this is 32-bit. That's the only difference. If I say that char x is equal to 25, you are changing the variable. You are changing but this guy also having address which is not shown to you. Now what is address? That is and x. That is pointer. It's as a pointer. Who gives the pointer? The compiler creates a table, symbol table, and put and x and put 1000. This is called fixed pointer. You cannot change. You cannot change. If you put here and x is equal to 1000, the compiler will give you error. See that because this you don't have a right to fix. You cannot change. This will be given by compiler. That's why you don't know. You think that it is writing x variable somewhere. No. The pointer is there. If you want to see that, you say printf %d, and x. You will know where it is stored. You will get the address. You can this is possible. You can read. You cannot write. You cannot change. But whereas Dennis Ritchie did one beautiful thing. He says that char star x is equal to 1000. Star x is equal to 45. Now, in this case, your data is a variable. Variable data and variable pointer. Understand? Variable data, variable pointer. Whereas in the case of char x, variable data you can change, but fixed pointer. You cannot change the address when you define like this. Now, finally, now you know that when to use what. When you're writing a program and you don't want to change the address, you can use just variable x, y, z. You say that I want to write where I like, then you should say star x. So when you define x or star x, in the case of x, x is variable. Sorry, x is variable and x is fixed. In the case of star x is variable and x is variable. And x is pointer and x is variable. Star x is. In the case of star x is pointer and star x is variable. It's clear now. So maybe if you don't understand, watch the video or ask me during the break. Now let us proceed to the very important, because if you don't understand that, I cannot do. So you can, as a programmer, you can write anywhere you want. Let us say if I have a microprocessor which has 32-bit address line. 32-bit address line. 32 means the address is so big. That means that from 000 to 32-bit to FFFF. You can write anywhere. You can write anywhere as you wish. You have a right. You define the program int star x. X is equal to right here 0x FF.
Sir, excuse.
Yeah.
Sir, small doubt, sir. Sir, this address 32 that we have written, so that is 2 power 32. That means that many bytes we are able to store.
Yes, exactly. Data. Exactly. Yeah, perfectly right. 4G. 2 power 32 is 4G. 4 giga. That is 4 followed by this much. Then think of it. A microprocessor which has about 40 bits. 40 bits. 2 power 40 is 1 tera. That means that 1 followed by this many zeros. Such a big. Okay. We are handling. You are going to handle it. When you move away from, initially you'll start practicing it 8-bit. Then we move to 32-bit. All the ARM processors, all the ARM microprocessors are 32-bit address and 32-bit data. You'll be surprised. Yeah, we are going to do that. Slowly we will move it to that. So don't worry about the address. Okay. Now the trick. I told you there are 4 components are there. We discussed the last class. One is read only. Second one is read only memory. ROM. Next one is read write memory. RAM. They are calling. Actually, RAM expansion is read write memory, not random access memory. Please understand. That's a mistake. The next one is write only. We call output. write only. And we have one more thing called input, read only. These are not memories. Whatever happening outside is coming outside interactive world. Now, what they have done was the engineers did a beautiful thing. Because of integration, I take one unit, 1 byte ROM, 1 byte. That means I have a signals, data, write and read. Understand? I have a data, write and read. When I give it, I'll be able to write any number. If I give data 75 and write as a 1, 75 will be written here. If I give a read as 1, then the 75 will come out. Now, if I don't give any data, 75 will be stored there. So there are 3 operations: write, read, store, or we call it as a memory. That is what exactly this ROM. ROM only. ROM we don't have a write. Sorry. Talk about that. The ROM you can only read. Sorry, I did a mistake. I've written ROM and I've written here. If the read 0 means data will be there, and read 1 means data will come out. But this is permanent. What engineers did was beautifully within the same silicon, in one silicon, they put 2 ROM first. ROM 0, location 0, location 1. But to select which location, I have a signal called address. That is only 1 byte, only 1 wire address. Then I have a data. Then I have, data is out. I have a read. So if I give this, let's say this is stored 75 and 45. If I give the address as 0 and a read as 1, then 75 will come out. If I give address as 1 and read as 1, 45 will come out. How it is working, we will discuss on our digital electronic class in depth. Right now, understand this. Then the engineers did a beautiful thing. They had 4 ROMs inside one chip. This is location 0, location 1, location 2, location 3. I have 2 address wires, data and read. When the address line is 0, 0, because 2 wires, because 4 location, 75, 45, 21, 31. If you give 0, 0, and if you give read as a 1, the 75 will come out. If you give 0, 1, and read as a 1, I get 45. If you give 1, 0, I get 21. If you give 1, 1, I get 31. So microprocessor can read any amount of line from here by giving the address. Then what they have done was they have put 8 locations, 0 to 7. So they have 3 address lines. So 0, 0, 0 to 1, 1, 1. Keep on increasing. Nowadays, you know that people have huge. Let us assume that I have about a memory of 1K, 1024. That means that 2 power 10 is 1024. So I have 10 address lines. So please understand, like a microprocessor, every memory is having address line. The microprocessor address line is out. The memory address line is in. Based on the address, whatever data, let's say you are giving here, now 10 wires, get from 0 to 1023. If you say here 465. At 465, if I have data of 41, that will come out on data lines. But you should do the what very important thing is read signal. Read has to be 0. If your read is not, read has to be 1. If your read is 0, data will not come out. Read has to be 0. You can have any amount of size, doesn't matter. You can have a memory of 15 address lines. What is 15? 2 power 15 is how much? 32K. That is 32,768 bytes. So this is the way they do that. All the chip, I get a ROM chip of the moment you see the address. If you see the address is 12, you should say that is 2048. You should know, or 2K. Same way, I have a RAM chip which has 14 wires. 2 power 14 is how much? 2 power 4 is 16K. Same way, I can have a output. I can have an output. Address line can be 0, no address line, then only 1 byte. Or I may be having 1 address line, then 2 locations. You can have any number, doesn't matter. Now the trick here is, I have let us assume that, let us take every equal number. I have a ROM of 32K. Let us take a small number. That's easy for us. Let us assume that 6 address lines. Easy to address. 2 power 6 is 64 bytes. Okay, that's easy to do the calculation. That's why I assume 6. Then I have 2 memories. I have a memory of 32 byte ROM. And they have a memory of 32 byte RAM. There are 2 chips. Now I have 3 chips. One is microprocessor, one is ROM, one is RAM. And the microprocessor, with the help of 6 address line, can address 2 power 64 bytes. But the ROM is read only, non-volatile. RAM is read write, but volatile. I want both. I want non-volatile to start the program. Please understand, the microprocessor, when you give a power, you should take the first instruction only from ROM, not from RAM. Please understand, that's a very important. All the microprocessor in the world, in your PC or laptop, your mobile phone, smartphone, whatever it is, everywhere we use microprocessor. That microprocessor takes the data only from ROM. That takes the data from the ROM. Please understand. Okay. Is it clear? Now, at the same time, I want to write into 5. I want the variables. That means I want a read-write memory also. So I need 2 memories. I need both. So one chip is ROM and another chip is, we call this as IC1. It's called IC2. Now, how are we going to connect everything together? That's a trick. How are we going to connect all of them to make a system? I buy a chip from the market. I buy a microprocessor chip. I buy a ROM chip. I buy a RAM chip. How are you going to connect? That once you learn it, that's a very nice one and very important one also. Is it clear? If you have any doubt here, ask me. So these are the three components we have. Yeah, tell me.
Sir, 64, 2 power 6, 64 bit,
No, I'm not. You are not audible. You can type the chat also. You can type the message.
audible now.
Yeah, now audible.
64 byte for the microprocessor which you wrote over here, addressed as 6, so 2 power 6, 64 bytes. And then for ROM you have written 32 bytes, and for RAM you have written 32 bytes. Are we splitting the microprocessor?
Yeah, that is what we are going to discuss.
Splitting the 64 byte into RAM and ROM?
Correct. That is what I'm going to do. That is what I'm going to do. Exactly, you're right. Oh, that you asked a very. I was about to tell you, but you asked. That is what we are going to discuss after the break. Next session is only that discussion. How the microprocessor is going to access these two. I have 3 chips, 3 separate individual chips. How are we going to connect them? That is a very important. And please understand, next session is very important. And go back home also, watch the videos n number of time till you understand. This is exactly what I'm going to discuss next session is exactly for the base for your computer architecture or embedded system architecture. If you understand the next session, you are great. That's it all. That's the most important. If you ask me that which is the most important session in the whole embedded system programming, the next coming session. Okay, after the break, we will discuss about that. I told you now, I am not in a hurry. I may extend this on, I may take one more extra class on weekends. I don't mind, but I want you to thoroughly understand this. The next session is very critical. It's very good. We have a ROM separate chip. We have a RAM separate chip. 32 plus 32 is 64. The microprocessor can access only 64. How are we going to make these two connect? Okay, that is what our discussion on next session. So let's take a small break. Okay, then we'll come back.